Let's continue where we left off with example number 4, solving a rational inequality. Alright, so you should have your notes in front of you. The first thing that we need to do is write in general form. Well, notice 0 is on one side, so that's great, but we need a common denominator. This one's easy. Alright, it's in general form. Look at your notes. Let's locate key numbers, zeros of the numerator and denominator. So looking at the denominator, we know the denominator will be 0 when x is 0. Let's look at the numerator. We need to come over here and do some side work in setting that numerator equal to 0 and solving. This would be a good place to do it. I'm going to add a 5x to both sides and then divide by 5. So we only have 2 key numbers in this example. That makes our work a little bit easier. Okay, look back at the guidelines for solving rational inequalities. Create a number line with the key numbers. So we have 0 here and 1/5 here. Alright, now up above, we don't necessarily put an open circle. It just depends upon what these values create in the problem. You could either go back to the original problem or the single denominator here, or the single fraction, excuse me. Let's plug in 0. Well, immediately you should see that 0 would be in the denominator, so we're going to have undefined above the 0. When you plug 1/5 into the denominator, you don't get 0. That's good. But when you plug 1/5 into the numerator for x, you do get 0 over 1/5. 0 over anything is 0. So these recordings above the key numbers have nothing to do with the inequality. It has everything to do with what happens when you plug those key numbers back into the original problem. So it looks like we have 3 test intervals. Numbers up to 0, numbers between 0 and 1/5, and numbers bigger than 1/5. This is going to be the kind of difficult area, but we'll tackle that when we get there. Okay, next step. Let's test some points in each of the intervals. So like -2 would be found over here to the left of 0, so -2. So I usually go back right here instead of the original problem. -2 in the denominator, or n for x in the denominator, would result in a negative denominator. So kind of keep that on hold in your brain. You have a negative denominator. -2 here, when multiplied by -5, gives positive 10, so 1 plus 10 is 11. 11 over a negative number, okay, or positive over negative, the quotient would be negative. Alright, somewhere between 0 and 1/5 would be like 1/10. If you plugged in 1/10 for x here, that's a positive denominator. 5 times 1/10 would give 5/10 or 1/2, so 1 minus a half is a positive number. So positive divided by positive would be positive. And let's be wise in our choice of a number that falls in this test interval or in this interval, like 1. Let's replace in for x 1 here and 1 here. The denominator is positive, but when you put 1 in here, you're going to get 1 minus 5, or negative. Negative divided by positive is negative. Alright, we're ready to report our answer. This isn't your answer right here. We need to go back and choose which values give us a positive answer. Well, that's going to fall between 0 and 1/5 because I have all those positive signs above the numbers that fall between 0 and 1/5. So that's your solution. Okay, let's look at one more rational inequality. Okay, it's going to be a little more complicated, but we will persevere. Our rational inequality, first step, put in general form. So we might want to first tackle getting 0 on one side of the inequality. So that's going to be -3 less than or equal to 0. Let's get a common denominator. Well, the common denominator is going to be x minus 5, so I'm going to have to multiply this over here 3 by x minus 5 over itself. Alright, so 2x minus 7 over x minus 5 is good. Minus. Alright, I think I'm just going to record 3 and then x minus 5 here. And then less than or equal to 0, because remember we moved the 3 over. Let's rewrite as a single fraction. Distributing the negative 3 would result in negative 3x. Distributing the negative 3 would result in plus 15. Let's do a little cleanup. 2x minus 3x is negative x, and negative 7 plus 15 is 8. So that's step 1 only. Okay, so I think that was a minus. Second step says locate the key numbers. Well, go to the denominator. That seems to be the easiest first, but whatever. X equals 5. Now what's also is a 0 of the numerator. You might see that when x is 8, you're also going to get a 0 in the numerator. If you don't see it, come over here, set the numerator equal to 0. I might want to add an x to both sides. Well, that's easy. X equals 8. So my key numbers are 5 and 8. We create a number line with those key numbers. Okay, we don't put a closed circle on both of them. Okay, what we do is we plug them in one at a time back into probably, maybe right here would be a good place to plug 5 in. So 5 in the denominator gives, for x, gives 0, so that's undefined, because you don't want a 0 in the denominator. When you plug 8 into the denominator, you're going to get 3 down here and 0 on top, and 0 over 3 is 0. Alright, let's test. So a number smaller than 5 would be 0. Plug in 0 for x here and 0 for x here, and let's see what kind of sign we get. So 0 here gives 8 over negative 5. That quotient results in negative. Okay, a number that falls between 5 and 8 would be like 6. 6 in here for this x in the denominator gives positive. 6 here would give us negative 6 plus 8, or 2. 2 divided by, or a positive divided by positive, would be positive. Let's try 10. 10 falls over here in this interval. So negative 10 plus 8 would be negative 2. 10 minus 5 is positive, so negative divided by positive is negative. Alright, so the solution, we'll look back at the inequality. It's less than. You want all the negative solutions, so negative infinity up to 5. There are more negative solutions over here, and that would be where 8 goes to infinity. A lot of steps, but just persevere and we're there. And you know what? I need to redo something here too. Do you see where 8 is? Okay, for that problem right there, we still have a 0 here because we calculated that we had 0 over 3. But when I look back at the inequality, I can have or equal to. So or equal to, when I look back at this inequality, means that I could include 8. Okay, I know that's kind of strange, but look at that. Let's try 8 in here. If I plug in 8, I'm going to get 0 over 3, which is 0, and 0 is certainly less than or equal to. It's equal to 0. So we want to make that adjustment here. Now the 5, it's still going to be a parenthesis because you get undefined. Okay, so that's solving rational inequalities.